As we are aware that the volatility is a command-based tool, but certainly the users used to face difficulty while working with the commands which are required to work with the volatility tool. As we have to identify the profile image of that particular dump volatile memory image. Also, we have to have the various commands listing with us, available with us. So in order to avoid the problem that have been faced by the users of the volatility tool, a particular GUI-based software, GUI-based tool that is named as Volatility WorkBench have been developed by the Passmore software development firm. So this particular tool, it can work. That means it can perform the analysis of the Windows memory image, Linux memory image, Linux-based computer system memory image. Also, it can perform the analysis of the Mac-based computer system memory image. Now we'll see in this particular video the demonstration of the volatility workbench tool in order to identify the some important information by performing the analysis of the dump memory image. So this particular volatility workbench tool is available for the Windows computer system, Windows-based computer system, and it is a portable tool. So this is the view of the Passmark volatility workbench tool. Various options are provided, various buttons are provided onto this particular as part of the GUI of this tool. So certainly we are required to have a dump memory image available with us in order to perform the analysis of the particular memory, analysis of that particular memory image. So what we have to do, we have to browse the image. First thing that we have to do is to browse the image. So let's say I already have done this particular image by using the dump item tool, and I will open this. Now, what is the platform? What is the type of this? Means whether it is of Windows-based computer system memory image, Linux or the Mac based, we have to select here. Thereafter, we have to do the refresh process list. We have to click on this particular button. Actually, the sequence how to work with this particular tool is given here in this command description text section. Like first, we have to browse an image by get a refresh process list, then select a command from the list. So we have to follow this particular sequence in order to work out with the various commands. Now, what are the commands that are available, which have been made available with the volatility workbench tools are, we can explore it now. The various commands that have been provided are given here. So one by one, we can select those commands and we can work out with this particular command. Let's say we select this first command, that is CMD line. So these particular commands, when we execute this by clicking on the run, it will provide the listing of all the process command line arguments. So for a particular process also we can select. So what are the process already just we have obtained? What are the running process were there running at the in that particular process we have identified, and we got the listing of all those process. So for a particular process, let's say take svc host.exe, we want to know what are the commands line arguments for that. So we can get that information by clicking on it. So certainly it takes some time as we have to go through the entire memory for identifying the required information. So on the bottom side you can see that the particular command is running. Okay, so for this particular process, that is svc host.exe, which is having the process ID 43324, this argument is given. This is the particular argument which is required for that particular process. Next command that we'll see is the DLL dump. So a particular process may require different kinds of DLLs. So we can, what are the DLLs which are required for the execution of a running process? We can get to those information by clicking on this DLL dump command. And certainly we have to dump at a particular location. So the name of that particular folder where we want to create a dump of all those DLLs which are required for the execution of a process where we want to store. So that we can specify here. The next is the DLL list. So it lists all the loaded modules in a particular Windows memory images. Whatever the DLLs have been loaded in the memory, that means which were loaded into the main memory at the time of the dumping of the volatile memory. So that information we can get from this particular command. So you can see various DLLs and where they have been loaded into the main memory. So like here you can see that for the svc host.exe process, so we are having number of DLLs like it requires the kernel 32.dll, scc.dll. So where they have been mapped. So this is the particular address where they have been mapped. So that details we can get from here. So this is how the information that we can get from the analysis of by using this particular command. Okay, the base, like here, what is the information that is being obtained? It is obtained in this manner: the process ID and the process, the base of that particular DLL where actually it is loaded. Thereafter, what is the actual size of that DLL? So that we can get here from this command. Now the next is about the driver IRP. So input output request packets. So certainly the Windows kernel has to communicate with the various drivers. So it is that information is sent in terms of packets. That is called as input output request packets. That input output request packet itself is a structure, and that information where actually that structure is available, loaded available in the main memory. So we can get the information about that particular packet by running this command. So there are various drivers are there, and the Windows kernels has to communicate with those drivers. In order to communicate with those drivers, some information in the forms of input output request packet is required to be sent to the particular drivers, and that is in the form of a structure. So we can get that structure from the volatile memory dump itself. Then the drivers can, so whatever the drivers are available, okay, so where they have been loaded into the main memory, we can get the information about those drivers from here by clicking on the driver scan. Then the file scan, so by using this one we can get the what are the files objects which have been loaded into the main memory. Okay, so that we can get that information. Then the handles, these commands give the handles which are open for a particular running process. So we are having the various kinds of process which are running. So what are the handles which are open for those particular process? So we can get that information. So we are searching for the svc host.exe process. What are the handles that have been opened? So we can have the handles of like a key type, then we can have file type. So those details we can get by this particular command. Then this particular command, that is info, this is going to give the information about operating systems and the kernel details of the memory image that is being done. So just we'll run this command, we can get some information about that dump memory image. So we can see here some information about the particular dump memory image. So where actually the kernel is available at that particular location, we can get this info is available here at this particular location. Then whether it is a 64-bit system or a 32-bit, so certainly it is showing that it is a 64-bit system. Okay, so that is being there. Thereafter, we can see what is the architecture. So this 34404, it is showing that it's AMD 64 architecture of the CPU. So that certain information we can get about your computer, the system itself, from this information command. Then the mal find, this particular command, by using this one we can find out the hidden and the injected code into certain process. So that we can get by using this one command. Then the mod scan command, so it is used for full scanner for the kernel models. So just we'll run this command. So we'll see the pools where that particular various kernel models have been loaded. So that details we can get by using this particular mod scan command. So on the bottom side, you can see the particular command is under execution. It is waiting we are getting taking some time to get the result. So we can get what are the various models and where they have been loaded of the kernels. It will take some time. Then another command is about the models. So what are the loaded models are there which have been loaded? Means list give the listing of all those models which have been loaded into the memory, into the volatile memory at the time of the dumping of the volatile memory. So these are the various models, okay, like which have been loaded into the main memory. So that details we can get various drivers have been loaded. It's then we can see those drivers here as part of this listing. Apart from the drivers, so we can have the various others models which will be loaded at the time of the execution of the certain process. So those details we can get from here by using the models command. The next command is a mutate scan. So the mutex related information we can get by using this particular mutate scan command. Mutex is used for is a mutual exclusion. So what are the mutual exclusion related information we can get by using this particular command. So then it's about the pool scanner. So it is going to scan the entire pools that have been used. That means in order to allocate the memory space for the various information or for various modules. So it is going through all the information and all the pages, and it is going to identify what is mapped in that particular page. So that we can get by this particular command. So it is taking some time. So certainly it has to go through the entire volatile memory. So we move on to the next command. So it is taking some time. Memory map. So what are the executable image which have been mapped into the memory, into the volatile memory at the time of the dumping of the volatile memory? So that details we can get by using this memory map command. So we have to select a particular process ID and let's say sms.exe. So if we click on this, right, this will unselect this dump folder name. So where this sms.exe where it have been mapped into the volatile memory, so that we can get from here. So these are the various pages, their addresses on the left hand side, and the various pages have been mapped onto those particular for that particular process ID sms.exe. These are the various the page addresses where that sms.exe have been loaded or it have been mapped into the volatile memory. Like here you can see the virtual memory and then we can the physical memory, actual memory where the particular that means these are the addresses of those particular pages where these particular memory that means the various pages means portable executable sms.exe, which is a portable executable sorry the executable file. So these particular pages which where it have been mapped the information about sms.exe file where it have been mapped into various pages. So that details we can get by using this as memory map command. Then next is about the PS list. So it lists the process present in a particular Windows memory mesh. What are the process we are running at the time of the dumping of the memory, volatile memory. So that listing we can get by using this PS list command. Next we see it is running. So you can see the MS Microsoft Edge. This particular process was running. That means there were many instances. Many tabs were open of this msh.exe. So that's why we're getting many instances of the msh.exe process. So we can get a listing of all the process where they have been mapped into the volatile memory. Then another command is a PS scan. So it scans for process present in a particular Windows memory image. So it is work as similar as that of the PS list command. PS list command. So it is going to be used in order to scan the particular memory image. So what the information we are going to get, the process ID, the image file name of that particular process, and the threads that are open for that particular process, the threads that have been created, the handles that have been open for the process. So and also its creation time and when it was executed, its execution time. So all those details we can get from this particular command. Then the PS tree, this particular command, it is going to give the listing of all the process in a tree structure. So we can have a parent tree, and the parent process may have invoke another process which is termed as the child process. So this representation is then all these things is being represented in a tree structure. Whenever the parent process creates a new process, so it becomes a child process. So how that particular process is, their hierarchical structure is represented by using this PS tree command. Then what are the certificates that are being stored in the registry? So like suppose uh, whenever you are trying to open some websites, so it asks for some certificates. So from the client side, the certificate is being sent to the servers in order to verify the authenticity of the particular sender or of the client itself. So in that case, those certificates are required to be maintained by the operating system. In case of Windows, those certificates are maintained in the registry. So it is this command, it gives the listing of all the certificates which have been stored in the Windows registry. Then the another command is about the hive list. So what are the hives? Hive actually is about for means is for creating the registries. So registry itself is created from the number of hives. So what are the hives that have been open in the Windows memory? So that we can get by using the hive list command. Various hives are like the software hives. Then you can have the default hives and user.dat. So default hive, those are also some of the hives which we can have, and where they have been loaded into the volatile memory. So that details we can get by using this particular command. Like a hive is a system hive, hardware hive, software hive that we discussed, security hive, SAN. So where they have been loaded into the volatile memory, so we can get the details from this command hive list. Same way the hive scan commands also work. It scans for register hive present in a particular Windows memory image. So we can get more details by using this particular command about the volatile hives, like the offset where that particular hives are loaded. Okay, so these are the addresses where particular hives are loaded. So that details, those addresses we can get by using this particular command. Then we can print the details of a particular registry key, because sometimes a particular process may require key objects. So the details about the key which have been used by a particular process, so that we can get by using this particular print key command. So what are the various keys? If you select this particular option checkbox, that is recursive keys, it is going through all the various keys which have been loaded into the volatile memory. So that details we can print by using this particular print key command about a particular key. So key is going to have the key name and its value. So that details, and also when that particular key was being lastly accessed by the particular running process. So that detail also we can get by using this print key command. And one of the key is the user register registry key. So we can specify mainly the details about the user registry assist registry key from this particular command. So this command, that is user assist, it gives mainly the information about the user assist registry key. Then SSDT command, it is going to give the information about the system call table. So that particular table whichever is created in the volatile memory, so the details about that table we can get by using this SSDT command. What are the system calls that have been made by the application program, so that details we can get by using the SSDT command. Then the statistic about the particular your volatile memory itself we can get by using this particular command. So what are the valid pages they are there in the volatile memory, then swap pages, invalidate pages. So those kinds of details we can get about the particular volatile memory itself in the statistic command. Then we can have the bad info. So a particular process, whenever it is mapped into the volatile memory, the ranges of that particular process means wherever it have been mapped. So those process memory range is specified by using the virtual address descriptor structure. So for a particular process, what are the bad structures have been created. So that details we can get up by using this command bad info. So a particular process may require different kinds of file which are required to be mapped into the volatile memory, and each of these map file is going to be represented, its ranges are going to be represented in a virtual address descriptor structure. So the details about that virtual address descriptor structure we can get by using this command, that is a var info. So we can select a particular process and we can identify what are the VAD info, what are the VADs are created for that particular process and where it have been mapped, where it have been stored into the volatile memory. So you can see the various VADs for LSASS.exe process that have been created. So you can see the starting virtual page number and the ending virtual page number. So by using these particular virtual page numbers, we can get the starting physical address and the ending physical address of a particular page. What is the tag for that particular page? Okay, so that also we can get, it is a VAD. So we can get that information from the tag. Then protection, what kind of protection is provided to that particular memory map page, like page read only, okay, page read write. So those kinds of protection is also provided to that particular process. Now what is the parent process for this particular process for which we obtain this particular sorry, the parent VAD, what is the is address, so that we can get by using this parent particular field. So this information we can get for a particular running process about its VAD which have been available in the volatile memory. Then version information from a particular portable executable file. So whenever the portable executable files are there, so it's detailed information about its versions and other things we can get by using this one. Like anti-os kernel.exe is a particular process. Okay, so what are its version and details? So these are the various the files which are available and their versions, products and build. Okay, so that details we can get the base address for where that particular NTS kernel.exe is loaded. Then the major and the minor, actually those details are not been obtained directly from the volatile memory. But certainly it is going to provide the details about that, the version information about the portable executable file. Then the list of virtual memory sections. So that also we can get by using this one. So these are the virtual map sections, the starting address and the ending offset. So those are provided here. Virtual map sections for the bootloader, the drivers, the hardware abstraction layers, and various other things. For the process space, what is the range of the addresses that have been allocated for the various processes? So that is being specified here by using the virtual map. The big pools, it gives the listing of all the page pools which are being there in the virtual memory. So it gives the description about the various pages which have been loaded into the means the information about the pages, the volatile memory. The cache information actually this is not available with this particular options, this particular the version. And in VAS, this particular command, it gives the information about the process environment variables which are required for the execution of a running process. So you can select a particular process ID and we can get the details about the process environment variables which are available for that running process. Then the service IDs. So get service IDs, SID this command. It is going to get the security identifier for certain process tokens. Okay, the process token security identifiers we can obtain by using this particular command. Create CID security identifiers for each process. So we can obtain by using this command. So if we execute this command, we'll see the various security identifiers. So security identifiers is given for identifying the users and the process, the for others also, and for the services also. So you can see the various security identifiers like this S154, S-1-54. So what is the security identifier which is being owned by a particular executable process? So this is the particular executable process and it is admin. That means it is being controlled under the administrator. So that is you can get that information. And also the users also can have access to this particular ca.exe and it is being identified by using this S1532545 security identifier. So how to work with a particular running process? So certainly some the rules are going to be identified, are going to be mentioned as part of these security identifiers. So which for those certain identifier is given and that have been identified with the starting yes series S1511. Then we can identify the process token privileges as in the previous commands. And also then we can get the signs of skeleton key malware. A kind of a malware that is a skeleton key malware. So if it is present in your volatile memory, it's running in the volatile memory, so we can check by using this one. So this volatility workbench tool, it has overcome what are the limitation of the original command-based volatility tool was there. Okay, so the user is required to type the commands. First of all, he has to identify the profiles, and then based on that, he has to use the lengthy command. So that have been shortened. The task of the particular analyzer or the investigator have been shortened by using this GUI-based volatility workbench tool. Apart from that, it also provides the facility of copying this information, whatever the result that we obtain for a particular command, so that we can copy to the clipboard and we can save it. So these kinds of facility have been provided by the Volatility Workbench tool. Thanks for watching this particular video. If you like this particular video, please click on the subscribe button to get the notification for the future videos on this particular channel. Thank you.